tagasi veerandi peale, et osa, kes Tartus loengutes käisid, et siis sellisel juhul jõuaks ka praegusel hetkel küll seda muret ei ole. Selle plaaniga sai
no jah, kui 3/4 lõpeb Tartus, siis veerandtunniga siia päris hästi ei jõua, täna oli veel mingi kiirus, on võeti ka tee ääres. Need teisaldatavad pildkast. Üsna siinsamas.
Ja põhimõtteliselt me saame striimida ka. Sain käima YouTube'i.
Praegu ilmselt pole küll enam kellelegi väga teatada, et vaadake otse.
Aga ta jääb ka järelvaatamiseks.
Aga siis saab.
Ma pean sulle kuidagi selle lingi saab.
Paluda vaadata, et ta uuriks, kas ja kuidas see asi. Aga siis juba ütleme, et järgmise nädala oma saaks selle sama, või millal see link, kuidas ta selle live streamimisele tekib?
Tähendab see, kui striimi käib, siis on ta olemas. Aga ta on lihtsalt mingisugune link, eks ole.
Et just selles mõttes, et kas on mingisugune link võimalik inimestele enne?
Ja seda saab tekitada. Ta praegu tegelikult praegu selle nurgas, see on minu isiklik YouTube'i kanal, mille kaudu ta praegu välja läheb.
Sul on arvuti, sa saad katsetada, kas see sul live stream töötab.
Kust ma selle leian?
Jah, ma pean sulle meili peale saab näha.
Siis on juba küsimus, et kas siis saab loodetavasti järgmise nädala seminari siis juba niiviisi laiemalt. Sobib see, kui seda järgmise nädala seminari niiviisi rahvale hästi näidata ette ja taha?
Jah. Aga võid Skype'is ka mõnda?
Mul ei ole siin Skype'is. Ma vorman siin keskjõude või te joonud.
Vist kõik tulevad kohale.
Ma tean, et audio võtme. Praegu ta nagu välja näeb.
No audio jaoks peaks olema mikrofon sisse lülitatud.
Mikrofon on seal laua otsa peal.
See?
Ei, mitte see.
Mitte see?
Natuke edasi.
See,
okei.
kuigi siin näitab linki. Ma saan niimoodi.
ma pean äkki ütlema, et kõik võivad vaadata.
Kopeeri hüperlink. Ja ta suunab kuidagi, paneb kinni.
Kindlat piiri ei ole, selles mõttes, et mingit järgmist asja
Ja ta
peale
suunab
tulemas
üld
ei ole.
YouTube'i lehele tagasi.
Aga tavaliselt on
minul on isegi niimoodi, et selle sama meili sees seda pilti kohe.
No ma ei tea.
kõige tavalisem. Aga vahetevahel, kui on niiviisi juttu jätkub, siis
Ja no nii
ja
on kirjas
see harjunud loengut pidama, et ikka kui alustada, et siis 1,5 tundi täis rääkida vahel ka seda. Selles mõttes, et üldiselt nagu rahvas tunni aega kuulab küll ära, pärast seda hakkab nagu paistab praktikas tähelepanelikult hajuma.
See on niimoodi veerukiri.
Aga nagu selles mõttes ei jah.
Kaks sisendit, kaks veerukiri. Võib-olla isegi live stream võiks töötada, ehk meie kaupa ei õnnestu
Poliitikaministeeriumi pooled, nemad uurivadki siis ainult, kui
Vastan
on mingisugune vastav seminar, kus neile parajasti workshopil räägitakse või peaksidki nad üldiselt hakkama uurima alles siis, kui on kõik valmis või kuidas see kommunikatsioon nagu praktilises elus käib.
Ministeeriumitega, ei me ikka räägime nendega iga päev.
Muutuste radari
või no mitte iga päev, aga tähendab
pisikesed ülevõtmised, sellest piisab täiesti. Mis teie kasu võib-olla hiljem tõesti näha, mis ta tegi ja võib-olla sealt mõni idee seda rakendusele.
Ma ütlen, et sobib, aga andku kirja põhjate.
Jaa. Sul võib olla ka suhteliselt lihtsas vormistuses, ei pea midagi. Kõige lihtsam toet. Paned oma blanketi peale ja ta saatis sulle selle projekti pealkirja ka.
Saatis mingisuguse jah, ML mingi dokiks.
kirja ma avastasin nüüd ja see oli 3 nädalat vana. Ma loodan, et äkki ta ei taha või.
Palju tegelikult selle ürituse ära tühitamine.
No ma mõtlen, et jah,
kirjutada
iseenesest seal on see formaat ette antud, see võtab natuke aega.
Ma tegin hästi lühikese ilus. Ma olen noorem mõte.
sulub, siis inimesi vähem kui minut enne.
ja ei, selles mõttes oli ka lihtne, et kui ma eile käisin, siis mul oli väga täpselt meeles kogu see ärakujutus ja jõud. Nojah, ei siin on paar slaidi, mida ma eile ka näitasin.
Veel 2 minutit sealt. Alustame siis kaugseire seminariga ja seminar ise saab nüüd olema inglise keeles, sest meil on mõned välisteadlased ka hulgas.
I was asked by Lea to speak about Rita remote sensing project and the part conditionally named fire in that. That is one of the 4 main tasks. And as was said, I was instructed to speak in English, and then I also prepared the slides in English. Rita, and I took the liberty to translate the name of the Rita program. So usually in the official documents that is kept in Estonian, but as I used a similar slide last week in a conference in Riga, where the presentation was in English, and I couldn't assume that they understand what the Estonian thinks, so I translated. As you know, Rita is about applied science, and topics are defined by the ministries, and one of the topics selected was remote sensing, and I think this is the only project where there are interests of 4 ministries. 4 ministries could agree with each other that remote sensing is important. Good luck for us. And so the tasks were formulated, and so it started. I will speak a little bit about the remote sensing project in general, then a little bit more about fire in it, and then a little bit even more, at least in the number of slides, about what we have done, mostly in development of fire hazard map, but also some hints on what still has to be done within this year. As we have 4 ministries, we have 4 main blocks. Ministry of Interior, who is interested, who is actually represented by the rescue board, is interested in how could remote sensing help in handling forest fires or landscape fires. Ministry of Environment is interested in how could remote sensing be useful for detecting floodings and stuff like that. Ministry of Rural Affairs is interested in crop detection, actually represented by agricultural registries, whatever it is in English.
Information board.
Information board, yes. And Ministry of Economic Affairs and Communication is interested in how could be remote sensing be useful for detecting how construction activities are going. And actually their interest started from, is it possible from remote sensing data to determine illegal construction activities. And then plus to the ministries we added, future block, which is about what are we going to do next year, because this RITA remote sensing will be over by the end of 2020, and but state could need more applications in remote sensing. So we want to offer them what could they need. And of course we have management and dissemination, which is almost always there. And now further I go to the fire. Specific research questions for fire are related to prevention and suppression of wildfires. There are 3 major parts in it. First, it is possible to make the fire hazard map better. Prediction of fire hazard, better, more detailed, and some activities are related to that. Then there might be some use of remote sensing during management of firefighting, spreading of fire and smoke, management decisions for relocating resources, etc. We have come to the conclusion that actually there is more need for geoinformatic analysis and tools, but some remote sensing using, for example, drones could be useful also during fire management. And then there is interest to assess how much damage was caused by the wildfire and how much damage appeared or did not appear due to brave activities of rescue boat or the rescuers. How much could they save, so to say. Now, all the projects have deliverables, so do we. And as there were 3 major questions, I have grouped the deliverables into 3 major fields. Better methods and technologies for compiling fire hazard map, better methods for wildfire management, and better methods for detecting the damage and evaluating it. This comes from the application phase, and it also has 3 major parts in it. The blue boxes are about evaluation of fire hazard. The red boxes are about fire management, and the green box is about assessment of the damages. Now, here, yes, some of the boxes are filled with green. These deliverables are done. What is not in green is not done. Now, all deliverables starting with number 2 are about fire. Deliverables starting with 3 are about floodings, and 4 is about crops, or what we call it, land. This shows that some part which formally is under fire actually is preparing data, input data also for other blocks, and that is basically meteorological data which is useful not only for fire tasks but also for agriculture and also for the water regime. Now, the full list of deliverables is here, and it includes 3 prototypes. Nobody knows what prototype is in this context. We have discussed it within the project. We discussed it yesterday here. I have discussed it with the research agency, and then from there I got explanation that they cannot ask analysis. They cannot ask overviews. So they thought a new term, prototype. Okay, they can ask prototypes. Because in RITA we cannot provide services. We cannot create final tool. We can only create something which is useful for creation of final tool, and it has to be scientific. Anyway, the prototypes are also 3 prototypes responding to the 3 major areas in this fire part of this project. Prototype for the fire hazard map, prototype for wildfire situation analysis, and prototype for assessment of damage. Now, by today in the morning, I showed some of it yesterday as well, but I thought about it further and updated it a little bit. So the prototype for fire hazard map is to be 2 algorithms. Algorithm for meteorological data input, algorithm for calculation of fire hazard, and also maps and algorithm or directions, guidelines how to update afterwards for the fuel amount. How much stuff we have, what can burn. And looking at sort of technical part, this is all some flow chart and scripts. Then we need example maps, fire risk maps in different situations, and also comparison between different maps as we compare different methods. And what is important also is that the rescue board has asked that they need some kind of explanation, which is called meta text here, what they could use to explain why fire hazard is that high as it is. Because based on the high fire hazards, they put limitations to people. You don't go forest, don't go there, don't go. Well, now maybe we don't need these restrictions anymore if everybody's told, instructed to stay strictly at home, and then we will not have this problem that much, at least. Although there are wildfires in Estonia which are not caused by humans. There are natural causes also. Although most of the wildfires what we have still are ignited by human activities. And this has been agreed to the representative of Rescue Board, who is very much interested in what we do, and that provides hope that we actually can get this thing useful and used by the Rescue Board. And now we talk about fires. This is from internet, one forest burning. We started with the data from Rescue Board. We have more than 7,000 fire events registered in Estonia from 2014 till 2018. They provided us that data. The data is not secret, but it's not public either. It's not open data. So we had to make a contract them because of formal reasons, because they are what Rescue Board does is not open. It is not all of it is public. So just for formal reasons, they had to make a contract with us to be able to give the data. I will show you some of the data. That is agreed with them. I can show this small part of data. Then there is a research done in 2017 about damage assessment. It is based on ecosystem services, which all normal ecologists and nature conservationists hate. This is a stupid term, but it provides a usable basis for damage assessment. And as it has been suggested already to them, my first idea how we're going to do that was also, okay, we will use these ecosystem services, because there are ways how you can put price to different aspects what may be damaged due to wildfire. Then there is weather data. Then we have two models. In comparison, we have analyzed a little more, but we stayed with these two. Nesterov is the one what is used now, and the other we call Canadian model. It is worked out in Canada in that sense. It is Canadian, but it is used quite a lot worldwide. And then, of course, there is different data about what we have in the nature, what could burn. RMK stands for Forest Department, or whatever it is in English. They know about forests, but also we have some other data. Now, from the weather data, actually it has been quite a lot of work, mostly done by the people at the Institute of Physics. What is useful here is wind and temperature and precipitation. Precipitation is, as understandable, actually the strongest factor having impact to the fire hazard. When it's wet and has rained a lot, fire hazard is low, and when we have had a couple of weeks of drought and it is warm and dry, then we have high fire risk. And also, what is completed, one of the deliverables, what was done by the observatory, the guy who did it is sitting here in the first row. By the way, you are co-author of this presentation. But I will come to that in the last slide. We know more about the structure of the forests, of the different kinds of material, what are there, and we know the amount of fuel better. Not only amount, but structure, different aspects of it, what is important. and it's probably more important not for fire hazard assessment, but for fire management, for prediction of how could fire behave when we have in a certain place fire. It's combination of wind, of course, but also how much fuel we have in different directions. That probably is useful. Now this is the data what they have. They have ID for all events. They have date and time, which is actually the date and time of the call. First call what was made to rescue board about that we have a situation. Then there is two ranks of fire, how big the event is or was. It maybe have preliminary and then also final. That means something what starts at low level might become big, but not always. One is the smallest. This could be a fire event when the rescue board was informed that there is like a fireplace a little bit out of control, and everything is solved within like 15 minutes, and that's it. And out of those 7,000, quite many are of that size. Actually, very small. We couldn't speak about large fires here, but there are some large events. Then there are coordinates. Both Estonian base map coordinates and geographical coordinates. But again, we have discussed with them quite a bit coordinates of what these are. These are most probably usually coordinates of the phone caller who announced or told about the fire. So it's not always exactly starting point of the fire. And by far it's not the center of the burning area. But this is the only location what we have. Then we have type of the fire. This is old grass, and it's about 50-50. Half of the fires are grass and half of the fires are forest. Then we have burned area, and then we have the column reason of the fire, which quite often is not fulfilled, and sometimes they don't know. With areas, it was clear from the beginning that during different years, different people have used different units. So there is only number, and sometimes the number means square meters, and sometimes the number means hectares. Because for sure, this is not very realistic. If it's second rank fire, it's not a small thing. It cannot be 1 square meter. It must be hectare. And from the other hand, there are numbers which would in hectares would mean that it was 1/3 of Estonia within one event. This has not happened. So those must be square meters. Then there is another table also which has less rows, but this is only about the larger fires when there is rank is higher, and here we have the number of units which were firefighters which were involved, and usually it took more days. 1 day, 2 days, 5 days. And we put these fire locations on map, and we can see that there is very strong correlation with settlement, where people live. They cause fires nearby them, around Tallinn, around Tartu, around Pärnu, around Kohtla-Järve, Narva, and it not necessarily is only wildfires as we speak. So actually there is an idea that we could and want to consider in evaluating fire hazard also, or the risks, also the probability of human activities which could be there. And then if we have high fuel, we have a very dry situation and high human probability, then those are the spots where we should be most careful. Today, fire hazard is calculated according to Nesterov model in weather stations, like around 20 weather stations, and then it is interpolated to Estonia. So what happens is that they calculate the fire hazard index for only about 20 locations in Estonia, and then interpolate the complex index. When it's blue, it's low. When it's red, it's high. The index is then generalized into fire hazard classes, and the classes are different. If you compare, for example, fire risk here and the classes and fire risk up there, they are different. The difference is for the period when no new grass is growing yet. That means we only have dry grass from the last year. And then the risk classes limits are lower, because that is dangerous stuff. When we have new fresh grass growing, the fire risks go down. That means the risk number could be higher before it is declared that it is like average or high. Now, the fire risk is calculated now based on temperature, dew point, and number of days with no precipitation. Pretty simple. Actually, it is a little bit more complicated because in the description of the algorithm, there are some parameter values which are important when you calculate, but what are not described in the general description. Like what means no precipitation? Numerically, it's important. It's important in sense it influences the result of the calculation. And like if you have precipitation per day 0.1 millimeters, if you are, say strictly no precipitation, that would, and the fire hazard index is cumulative. That means you have the last day's index and then you add the new day's impact. So one rainy day brings it back to zero. If the 0.1 is a rainy day, it could stop the number of days without precipitation, and we start from zero again. But if it's not, if it's considered actually it is no precipitation, then it does not go back to zero. So there has been a lot of analysis of these small things. The Canadian model actually includes different submodels. Fire weather index, this leftmost one is comparable to the fire hazard index calculated using Nesterov, but the system also has fire behavior prediction system, which could be useful for this fire management part, and they develop still further more complex parts. Now we are speaking about applying this fire weather index primarily, and maybe a little bit of this one. It has 7 input parameters. Moisture content of fuels, fine fuel and DUF. So they separate between litter and other cured fine fuels in one group, and loosely compacted organic layers in the other group, because the ignition probability is different for the different things. Draft code, which is average moist content of deep compact organic layers, basically this is very much related to the length of the period without precipitation. So we can see similarities in two models. Initial spread index, how fast the fire starts to spread. Build-up index, total amount of fuel available. Fire weather index, and this is the result of the complex index. And then there is daily severity rating, which is based on the fire weather index, but more accurately reflects expected efforts. So it starts to evaluate also how much effort you need to stop the fire. It means something for firefighters, not only the hazard of having the fire. And some examples from Canadian side. Well, numerically it is very much different from the Nastero, but that is no problem, it doesn't matter. They both grow higher with higher fire risk, so the lower the number, smaller the number, the easier the situation is. And here we can see very low risk situations, the fire would be slow, and there is considerable probability that it will just go out itself, until then large fires, which is total forest burning. Now, the Canadian model is used by different international undertakings as well. Like Copernicus has fire prediction system EFIS, which is using also the same Canadian model. And this is a map of fuel. I don't remember now what is what, but I just like, I have not changed the colors, so this is originally how it comes from the Copernicus services. Quite diverse Estonian nature. And this is an example from the Copernicus service of fire index. They calculate it also by cells, and green is lower, yellow is higher. This is basically a relatively easy situation. That means the fire index is not very high. Also a site called Firms uses Canadian model. Nothing burning on this picture in Estonia, but there are quite high fires in some places worldwide. It's used for fire detection and also for monitoring of the fire situation, how the fire is developing, how it's going, because sometimes, as you know, like this winter we had, or Australian summer, we had large wildfires in Australia, the world, which lasted several months, and probably there's maybe something still burning there. So monitoring of that makes sense. Now, we could ask if we have Copernicus services and firm services and then also there are more. What do we need to develop them? Isn't that enough? Unfortunately, it is not. But before going there are some things what I want. I want to pay your attention to. You to pay attention to. It's like this red line. I don't think this is fire. This is some error in data.
Or processing.
Data or processing, yes. That means this is what we see from the imagery is not 100% true. Everybody who has worked with remote sensing knows it, but ordinary people tend to forget sometimes. Whoever are ordinary people. An example from the firms, you can also see the satellites flying over, and there are different orbits. Rising orbits and declining orbits. Escaping. Yes. Descending. Yeah. And also they have timing on their trajectory. So and then even the coverage, temporal coverage, seems to be high enough. That means we have several satellites going above us close enough that could notice the fire. Several every day. So that would mean maybe it's good enough temporal resolution. But in the spring of 1919, there was a fire in near Pärnu, where altogether 17 hectares of old grass burned. The fire started 15 minutes after the satellite went over. And as it was next to town, it was discovered immediately. Rescue started to work immediately. There were houses nearby, and they started to saving the houses or making sure that the houses don't get fire. And then it was open place, very easy to access, next to road, no accessibility problems. So they could turn down the fire before the next satellite came. It took about 3 hours for them to close it down. Next satellite came a little too late. So this is an example from or about that we don't. Well, maybe this is still not enough. What we can see from satellites. Maybe we can do better if we look at things in more detail and more closely. That particular fire was actually detected by satellites. Somebody searched it out in Sentinel, not the visible, but some Sentinel thermal or whatever image afterwards. That means knowing that there was a fire and searching it carefully, he could detect that, yes, there is an image which has seen this. But not this fire monitoring service. Another mistake here in the fire monitoring, there is a permanent red dot in Estonia. There is all the time forest fire according to these satellites. It is Kunda cement factory. They know it. Americans who are developing it know it. There was one guy who is developing it in Estonia last autumn, so we discussed it, but they don't know exactly why it comes. and how to get rid of it. What changes should be made in the algorithm to get rid of that? Probably there is some extra heat which is detected by the sensors and translated as a wildfire. Well, this is the burnt grass near Pärnu, where the fire started, well, caused by human, but actually we even cannot say that it was carelessness or whatever. The car just to turn around turned into the grassland and then left back to the road, and something what came out from the whatever is summuti in exhaust, yes.
Exhaust system.
Yeah. Started the fire. But it was very dry period then. Here I have fire index maps. It was sometimes in April, and by early May it had already gone down. Fire index is not that high, but in April it was really very high, and the grass was very dry. There was no green grass yet, so it could be ignited very easily. These are the maps from, so to say, official, how they are produced now. This is an attempt, what we have done for the same 3rd of May last year. Now based on calculation on the field in sense, in the mathematical sense, like cluster covering the whole Estonia. And now we reach the part where I'm going to talk about no, not yet. Where I'm going to talk about what method we are suggesting to be used instead of how it's done today to make things better. But this is an example. There was a visiting researcher from Ukraine in the beginning of winter here, and he basically is a computer scientist and developer of internet things, and he wanted to make a very slim internet page. That means very little demanding, small but still working, still useful. So I told him, okay, you make it on fire data. And it is a tool, well this is just a screen still, but the tool which can be analyzed, there are 10 years MODIs and 10 years data, 10 to 19. So you can pick out by year any of the sources, or you can take all years, both sources, and then look at how the fires are spread over Estonia. You can look just the fire dots. You can look at as heat maps, but here this is progress mapped by municipalities, and the number of fires has been calculated per square kilometer, normalized. So this might be useful for interested people in public to play around with fire data and become more knowledgeable. One more example from satellites. Earth Orbit browser allows to look at different layers. This is false color based on bands, whatever it is, 8, 4, and 3. And there was a fire in Oisaare. Here. So it's a little bit seen here, and it's in the Pärnu County. We can also see the moisture index, and this is a landboard aerial imagery from the same location after the fire. We can see the region there is some visible impact. Now, block or flowchart of the suggested methodologies here. We have two input blocks, meteorological data, temperature, wind, precipitation. That has to be renewed on daily basis because the situation changes every day. And then we have maps of potential burning material, which can be, or it has done once the situation when we finish this project, and then it probably needs to be updated annually. It doesn't need to be updated every day, definitely. Well, maybe forest clear cuts could need updating more often, but that becomes more theoretical. I think nothing bad happens if that is calculated, just renewed every year. Then we have to do some preparation with the data, and then we calculate fire risk index. We have left at the moment to choose by the people who have to do it afterwards. That means not the development phase, but when it is really applied, whether they want first to use to keep to the Nesterov model, or they use the Canadian model immediately. I don't know that choice yet, but it will be clear this spring. And then we have the fire map here, and then we generalize into risk classes, and we can determine it by municipalities or whatever. Now, meteorological data prepared by the people from Institute of Physics is based on wind and temperature is Medcorp harmony model. Precipitation is Estonian weather radar and adjusted to data from weather stations. And that adjustment, using the weather radar and adjustment both cause some problems, but altogether they are getting pretty good fit. They are happy. Although there are still some problems, there is some radar data missing. Simply for some days, for some reason, I don't know exactly what, there might be different reasons. Birds, bugs, something, some obstacles, conditions for radar spread, whatever. And sometimes it underestimates or overestimates. There are some regions, like rays from the radar, where the data is missing or usually mostly wrong. And from the final data set, what we were provided, there were values like 300 millimeters per 3 hours, or 600-700 millimeters per day. 600-700 millimeters is an annual precipitation per Estonia. The maximum daily amount ever measured is 148. So 300 cannot be true for 3 hours. Maximum measured for 10 minutes is 10.3 millimeters, which would give for 3 hours 41.5 millimeters. But in the case that you would have the same intensity of rain which was measured in 10 minutes going on for 3 hours in a row, which is not usually happening that way. So at the moment what we can do is only we can put the limits, and whenever the number is higher we use the maximum possible. Now we have, this is where Mait is co-author of the presentation, it is from his work. We have the forest location, different species, different types of forest, and then, well, this is not all the work, this is just to show here And then based on LiDAR data, we can, it is possible to know something about the structure within the forest, which is also useful. So we have evaluated that getting values for this that are needed for the Canadian forest is possible for Estonian forest. We have enough knowledge to be able to calculate those parameters based on what already is collected, what data already is collected. We don't need extra special data collection program for that, which is important. Now also we have red beds, bogs, grasslands. Red beds mostly are located on the west coast. Yellow ones are grasslands. Then there are peatlands, which all are also potentially burning material. Now with the grasslands, it is there is a question, but probably that can be solved also. We would need to know whether the grass was cut in the fall, that means in the spring there is no high dry grass, or it was not cut, and we have a lot of burning material. Maybe that, last week I talked to a lady from this agricultural registers administration, information administration, and they actually might have, at least for many pieces of land, that knowledge as well. So it can be solved. And now there comes a series of fire risk interpolated maps. Here we have, in the upper row, we have fire index interpolated based on the stations, how it is done now, and then the risk classes. And here we have fire index calculated based on, this is still using Nesterov model to make them comparable, based on the precipitation data and meteorological data by square kilometers all over Estonia. And then the fire classes. We can see that there is more detail here. There is more variability. Mostly these interpolations have been done by Edgar Sepp. Now other people are going on with that. Another example, yes. And now we come to a series from 2018, which was a very bad year from point of view of wildfires. Well, bad in the sense we had a lot of wildfires. We had a long dry periods. 17 and 19 have been quite different. What's going to happen this year, I don't know. But probably spring will not be very high fire hazard because the grass is already growing. It has not become dry, but grass is already growing. We will not have a long dry period with grass not growing. But yet the same pattern, the way how weather service calculates it and the way what we propose. And now the fire risk goes higher. April 12, May 20, fire risk is already quite high. We think it is the highest class. Here it is still the high, not very high. And now we come to June 5, where there probably have been some small precipitation events in some weather stations. So how it's calculated now shows more diverse picture. Here we don't see, everything is very high. And what happened on June 11, he started the largest wildfire last year in Vikipalu, or one of the large ones, and some photos from the rescue board. And the Sentinel pictures a week later show the burning as well. And now, a few days after the fire started, it was still burning, and the risk started to go down. We had some precipitation events in some places. Again, we see some similarities between the spatial spread, but still some differences. Now, why we think the new way is better? It has better spatial resolution and more precise meteorological data. It has more detailed knowledge about the potential fuel. So 2 points where input, just improvement of input data should make the fire hazard assessment better. And then we calculate it differently. We don't interpolate a complex index like it is done now, but we calculate based on square kilometer cluster. And then whether this makes it better or just different, I don't know yet. Then we could also consider lightnings. There are services measuring lightnings as a natural cause, possible natural cause of wildfires. And that's it. Thank you.
Any questions?
How well are correlated high fire risk and real fires?
Not very well. And the problem is in statistics, fires are stochastic events. And fire and non-fire, they are not symmetrical. That means the rescue board itself is doing a high effort to avoid fires, and in particular, careful are they when the risk is high. So the high risk does not necessarily mean fire. But there is some correlation in terms when the risk is very low, everything is wet, there is no big fire. That is clear. So all the big fires have occurred in the high risk periods when it's dry. You can try to start the fire now. It's quite hard, doesn't? And then usually, most probably, it will just go down itself very soon. So high risk and large fires, low risk, no fires is there. But in high risk, we also have a lot of non-fire days.
One question. I mean, it's interesting that the fuel load is included in the model, right?
Yeah.
But I'm just wondering that somehow that, like the fuel load and the fire itself, assuming it took place in this area, they will somehow it will be back coupled somehow, because the fire itself could change the fuel load regime of the spot. You know what I mean? So it's usually when you consider that the amount of deadwood is increasing the probability of a fire, and once the fire took place, like deadwood in the forest needs some years to accumulate. So once it is gone because of the fire, theoretically the risk score of this place should be scored down, right? At least for some years.
Yes.
So I'm just wondering if the model is considering this, like in the future, when you just assuming, like when the fire frequency is low at all, it will not change many things. But assuming that the fire frequency will increase in the next decades or years, many spots will have an altered fuel load character.
Mm-hmm.
And therefore I'm just wondering how you deal with these back coupling things.
I don't know exactly yet how, but we are trying to consider it. That means with the annual reviews of the fuel material, it has to be considered somehow if it's changed. Now, actually in Estonia, this problem is not very important. It's less important than in some other places worldwide, because most of our fires are small, and is actually the amount of fuel what is burned is not high, and that's mostly of that fine stuff, which comes every year again and again and again. Usually our forests are relatively wet, humidity is high, and decomposition and stuff like that happen all the time. So it's not a dry bushland like in Australian case. But with the Australian fires, and it has been also earlier discussed, and it's discussed quite a lot in scientific literature about forest fires. In the case of Australia, there were people who said that it had to happen because due to human activities we have preserved a lot of fuel. We have accumulated a lot of fuel. It has not burned that normally as it burns under natural conditions, so we made the situation worse and worse and worse, more dangerous all the time.
It's actually true. I got the same thing, that in some countries they observed that since the years before they have forbidden like camping fires and bonfires. Usually people cleared up the forest because they were burning the things in small fires.
Yeah.
Then they have forbidden it, and then it accumulated over some years, and then it increased the. It sounds a little bit paradox, but the risk avoidance has increased the risk of the wildfires in some countries.
Yes, there definitely is that, and worldwide there are attempts to use controlled fires, for example. Then there are Northern America, Australia, there are regions where there are much more fires than in Europe. And they are trying to use prescribed fires and controlled fires in nature conservation areas, for example. And there have been discussions that Jack Pine, Pinus banksiana, which was here also the fire index classes example, that it has cones that don't open at all without heating up enough. There is research. There are other people who say that is not 100% true, but definitely there is. So that is an example of species which somehow has adapted to.
Yeah. So, but I think that also in the Mediterranean and Europe, this serotiny is so some very many conifers also in Europe are adapted to fire regimes, and without fire they couldn't regenerate naturally. So.
And well, in our Australian folklore, that means native Australians who went there just 50,000 years earlier than the others, they consider fire as a creator of new opportunity for nature. I mean, all stuff is burned, and then it gives the new grass opportunity. Actually, this has happened in Estonia also. We have had the culture to burn the old grass every spring. Now it is forbidden to avoid fires. But if I take 20, 30 years ago, springtime burning of the old grass was a very common thing. And my darling sister burned down half of my construction because it started to burn grass around that, and then a little more went. But luckily the house was not ready. It was just, it wasn't house, it was a cover above the cellar. So it may happen, yes.
More questions? If not, then we can close.
kunstpärane.
kas need sademete kaardid hakkavad siis
soliidne
tekkima
raamat.
kuskil kaulis kuskile pakki või?
pärast, jah, jah. No kaur peab, tähendab,
see realiseerima.
praegu me teeme, Valentiin on vaadanud ikka kaardina, eks ole, ja ta töötas neid andmeid, aga lõpuks peab ilmateenistus hakkama tegema, eks ole, jah, käima panema ja hakkama iga päev uurima.
kas need, ütleme, kui sa võtad mingi kvartalite kaupa summad, kas need lähevad lõpuks kokku ka, mis on meteojaamades mõõdetud või seda ei ole vaadanud?
Ei, tähendab, meteojaamades lähevad kokku, sellepärast et füüsikud Jorma kõige rohkem, mis nad tegelevad sellega, kalibreerivad radari andmed mõõdetud andmete järgi. Nii et nendes mõõdupunktides aetakse andmed kokku.
Lihtsalt ühesõnaga seal rohkem valideerimise võimalust ei ole?
Täiendavat ei ole, sest no okei, teoorias saaks mängida, et võtame pooled ilmajaamad ja siis, eks ole, ma ei tea, kas nad on seda teinud.
Kuule, tore, tubli oled, et käid esinetud tutvustad.
Tegelikult
tahtsin sinu käest hoopis küsida, vaata see, mis Astra kohta saab. Ma kirjutasin vastu, et ma ei tea, kas ma rääkisin natuke Karinast.
Mis ta arvas siis, et
me vaatasime neid abikõlbulikke asju, et ma nagu ei näe nagu hästi väga just see teenuse pool, et seal on tegelikult ainult üks kriteerium, kui palju kaasatud ettevõtteid suureneb. Seal on ainult üks kriteerium,
seda ei tohigi seisma panna.
Siis ainult selle eest võib panna.
see on väga palju üle.
Ma ütlen, et meil on praegu minu see Baltic setup, kus tegelikult me näeme, et kaugsed ettevõtted Eestis, 1, 2, 3, 3, 2, 1.
Me saaks kõik kaasata ja 100%
kaasata. Kuidas meil suureneb kaasatud ettevõtte arv, kui palju see suureneb?
Aga nad ei ole kaotatud praegu.
Läks natuke üle midagi meil.
Aga mitte väga. Aga saaks 25% kasvatada.
Jah, ma mõtlen, et seal on nagu see jah, et aga meil mõttekohta tegelikult nagu võiks olla, et ja seal on teine asi muidugi seal nagu võrdsuna see laborite akrediteerimine.
Jaa, no seda ei võttes, et see tuli puhtalt selle aastal.
Jah, seda saab, ja see on seal välja, et see on ka nagu praegu veel nagu natuke mõtlema, et selles mõttes, et
see võimalus on olemas.
et aga võiks nagu tõesti